In this video, we will discuss about step response of RC circuit. So we already discussed source-free RC RL circuit in the previous videos, and here we are going to discuss step response. So what is the difference between step response and source-free responses? Whenever there was a switch closed in source-free circuit, the source was suddenly removed. But in step response, whenever the switch is closed or open or something else, then there is a source suddenly appeared to the circuit. Then how the response will look like, that is what we are going to see in the step response. I hope you understood. So to calculate step response, this is the formula. We are going to find out what is the total response of a circuit either before the switch open or after the switch open, and whether the new source is added suddenly to the circuit or whether we have a previous source already available in the circuit. So we are going to include all these things to find out the step response of a circuit. And here this is the formula V of infinity. This is transient response. This is also transient response. And here we have a initial condition. It is called steady state response, where there is no change. And as usual, the response which is decaying, because we have e power minus t term. So this is decaying with respect to time as well as the time constant. Okay, so we'll see a simple problem to understand how the response looks like. So this is a simple problem which we have taken from Alexander Charles' book, where we are going to find out what is Vc of t across this particular capacitor. And Vc of t means we want to find out initial value as well as the final value to calculate the total response. So initial value is V of 0, and the transient value, how the value is decaying, that is actually called transient response. And finally, the addition of transient as well as steady state response is called complete response. Okay, so first we want to find out before the switch is closed. Our switch is closed at t equal to 0. We want to find out the initial condition, which means what happened before the switch is closed. Before the switch closed means we need to have a condition which is less than 0, because switch closes at t equal to 0. So before means it is less than 0, after means either greater than or equal to 0. Okay, so before the t less than 0, switch was open, because at t equal to 0 switch is going downward. Okay, so the switch was open means this particular area will not appear here. So only we have a circuit up to here, and we are going to find out what is the initial voltage appear across this capacitor. So t less than 0, and this is the circuit we got from the original circuit, and we know capacitor is open circuited for DC voltage, and we want to calculate voltage drop across here. Since it is open circuit, the entire voltage will appear over here. 2 is an invalid resistor as it is open. Okay, so we can assume that the initial voltage V of 0 or Vc of 0, which is the voltage drop across the capacitor, will be the same voltage 10. This is for the condition t less than 0. And then we want to have this one. After switch closed at t equal to 0, which means t greater than or equal to 0, what will happen in the circuit? Switch is closed, and we are going to find out what is the voltage drop across the capacitor location. Okay, and we can use any methodology to find out Vc of t, but what I have done is I have taken nodal analysis. Okay, so this is the node point V location, and since it is open circuit, we assumed as Vc of t over here, and for simplicity's sake I have taken V here. Okay, as per the nodal analysis, this will be V minus 10 by 2, that is what here, V minus 10 by 2 plus V, this is minus plus, so we want to take minus 5, and according to nodal analysis this is V minus of minus 5, okay, divided by 6. To understand more about nodal analysis, I have given a separate videos, you can take a look at that. Okay, and after that, by just simplifying these formulas, V plus 5 and taking LCM and bringing to the next side, the value will be 4V is equal to 25, and finally V is equal to 6.25. So 6.25 is the value we got for this particular Vc of t with this source and this source after the switch closed. And then we want to find out what is the time constant value. And as we already know, time constant means we want to short circuit the voltage sources because we want to calculate our equivalent model of the particular circuit. So short circuit the voltage source, open circuit the current source, and here we are going to short circuit the voltage sources, and we are going to find out the value equivalent value at this particular point, where the capacitor was located. So in this point means this resistor 6 ohm starting point as well as 2 ohm starting point, both are same location. Similarly ending point also same location. So this is parallel combination. So parallel combination is 2 into 6 by 8. Finally you will get 1.5 is the equivalent resistance of this particular circuit, and we know what is R equivalent, and we can calculate tau. Tau is equal to R into C, and R value, equivalent value is 1.5 into C value is 1 by 3 from the given problem, 1 by 3. So we get 0.5 is a time constant value, tau value. Okay, and we want to take all these tau value, initial voltage and final voltage, final value V of infinity, all these things into the formula. So final value was here V of infinity, okay, and V of 0 is initial voltage with this time constant. By replacing all the terms with the numerical numbers, where we got V of infinity is 6.25 and V of 0 initially we got 10 and minus 6.25 into e power minus t by 0.5. 0.5 is your time constant, and if you do so, we'll get after subtracting this, you'll get 3.75, and the final voltage V of t is equal to 6.25 plus 3.75 into e power minus 2t. So this is a practice problem in Charles Alexander book, where you don't have any solution in the book, and this is the solution, and you can check the answer also. This is the same answer, where the answer portion that gave you the answer. Okay, so this is how one has to solve the step response. So the most important thing is we want to check how the switch opens or how the switch closes, and as well as if it is a step response circuit, then we want to use the formula, this one. And how do you find out it is a step response? So whenever you close the switch, you will get a sudden voltage addition into the circuit, okay, most of the cases.